Hello and welcome back. Today, just a quick video on a limit, something a little bit unusual. Limits have come back into the syllabus now, into further maths, I believe. So you do limits by series expansions and limits by L'Hopital's, but this is a little bit different. It requires kind of like third conjugate manipulations. So it's a limit of this quantity as x goes to infinity. So you can see that we have the square root of infinity, which of course is infinity, minus the square root of infinity, which is infinity. Infinity minus infinity, this is zero. Oh, I don't know. Actually, it's a nothing. It can be absolutely anything. So at the moment, this form is kind of like bizarre. And we will manipulate it as follows. So this is what we do for a limit like this particular one. I'm going to conjugate it in a third sense. So let me write it first of all, and then you can follow better what I'm doing. Okay, because of this kind of situation that just arose, I'm going to multiply top and bottom of that over 1 that I've just created by the third conjugate. And the third conjugate is, of course, creating a difference of squares in this particular one. So it's going to be a plus version now. If it was plus, there will be a minus, of course. So we got that. And we need to do exactly the same on your denominator, plus the square root of x squared minus 1. Pardon me. A little bit of a tidy on the top. A minus b, a plus b, so that's that squared minus that squared. So it's going to be x squared plus 2x minus 1 minus x squared minus 1. And on the top we have, sorry, at the bottom, sorry, we have a similar looking expression to what we had originally. But of course now we have a plus between the two quantities. So let's fully simplify and let's consider our last move. So the limit as x goes to infinity, x squared minus x squared gone. We got a 2x minus 1 plus 1 cancels. So this, I don't know if you can call it simplified. We're going to check in a minute what happened in there. Pardon me. X squared minus 1. We have a similar problem. X goes to infinity. We've got an infinite numerator, and now infinity plus infinity, more infinity, infinity divided by infinity. But now we have an option on the denominator which we didn't have before because of the plus. Have a look what I'm going to do. I'm going to factorize out of each third an x squared. So when it comes out, it's an x. I could, when it comes out, should really be mod x, but because it's to plus infinity, I have to assume, unless they're putting a plus or minus infinity, this is large and positive. I don't really need moduli. So here, for example, I should really be writing it like this. 1 plus 2 over x minus 1 over x squared. So this is the third, the radical, and it should be written like that. And similarly, I'm going to do the same thing on the other one. But for this particular one, that is what I was just explaining. We don't really need moduli because x is positive anyway. So I would have written it just simply as an x. Is that good? I think it's magnificent because we got 3 terms, 1, 2, 3, x, x, x. Goodbye, my friend. So this is equivalent to the limit of 2 over the square root of 1 plus 2 over x minus 1 over x squared inside the radical plus the square root of 1 minus 1 over x squared. Does this limit exist? What happens as x goes to infinity? By, and by. I don't want to be rubbing off and rewriting, so this one is now the same as 2. I'm taking the limit, square root of 1 in the limiting case, x goes to infinity, plus the square root of 1, which of course is 2 over 2, which of course is 1. And this is this particular limit. Is this limit hard to compute? The answer is definitely conjugating is actually quite a standard technique when you see square roots in limits, which at A level you don't get to see a lot of them. But of course afterwards this factorizing of the x is something that not a lot of people might have thought about it. So yeah, quite a challenging limit, a little bit different to what you're likely to see in your standard exam. Okay, I'm going to be signing out. I'll see you real soon. Bye for now.